Hi everyone, in today's lesson we're going to review all of the important exponent rules that you will need to be successful in this unit. The first rule that we're going to review is how to multiply exponents with like bases. So if we have an exponent or a base of x and an exponent of a, and a base of x and an exponent of b, when we multiply them we just add the exponents. And if there are any coefficients we multiply them. So x squared times x to the fourth is you keep the base, you add the exponents. For number 2, we're going to multiply the 3 and the 9, which gives us 27. Keep the base, which is an x, and add the powers, you get 6. There's technically a power of 1 here, so this makes this 5 plus 1, which gives me 6. Number 3, we're going to multiply 7 and 1, which is 7. Keep the base of an x, and add the exponents, which is 6 again. Number 4 is another way of writing multiplication. So it's the same thing as saying 2x times y squared, x squared. So we're going to take the 2 coefficient, multiply it by the 1, which is out here, so that's 2. Now we're going to multiply x and x squared. This x has a power of 1, so we keep the base, add the powers, and we just tack on that y squared because there's nothing to combine it with. Okay, number 5. This one's a little tricky. A lot of people want to take this 3 and multiply them together. But be very careful. This 3 is the base that's attached to each of those exponents. So you keep the base and add the exponents. So we're going to add 2a and 5a. So this becomes 3 to the 7a. Okay? Now number 6, same concept. The common base is y. So we keep the y and we add the powers. b minus 1 plus b plus 3. So my final answer would be to combine the like terms. So I have b plus b, which is 2b. And then I have negative 1 plus 3, which is 2. So this is my final answer. Okay, next. We have dividing exponents with like bases. The rule is relatively the same, except we're going to divide coefficients and then subtract the powers. So number 1, the answer is simply a squared. Subtract 5 and 3, keep the base of a. Number 2 is x to the 8th. There's an exponent there of 1. Now number 3, be careful. The 3 is the base, not the coefficient. So we keep the base and we subtract the 4 and the 3. And we get 1. Now 4, 5, and 6 are a little bit harder. They're going to require you to simplify the numerator first, then divide. So number 4, we're going to multiply 4 and negative 1. We get negative 4. Keep the base, which is x, and add the powers. 8 plus 2 is 10. Put this over 32, x to the 7th. So now I can divide negative 4 and 32. And that will give me negative 1 over 8. And I divide the powers, x to the 10th and x to the 7th, and I get x to the 3rd. You could leave it like that, or you could put x to the 3rd on top with the negative and 8 on the bottom. So either way is the same. You just can't put x to the 3rd in the denominator. Okay, number 5, again be careful, the 10 is the base, so you keep the base, add the powers, over 10 to the 6th. Again, keep the base, subtract the powers. Okay. Now number 6 is fun. Again, keep the base, but we're going to take the 2a plus 9 and subtract a plus 8. Now you should be asking yourself, did I write that right? And the answer is no, because when I subtract a plus 8, I have to remember to distribute the negative. So it's really 4 to the 2a plus 9 minus a minus 8. So 2a minus a is a, so 4 to the a. 9 minus 8 is 1, so 4 to the a plus 1. Awesome, let's move on to the next page. Next step is raising a power to a power. So if I have a power inside the parentheses and I'm raising it to another one, the rule is as simple as keep the base, multiply the exponents. So this first one would be a to the 6th. I multiply the 3 and the 2 and keep the a. Number 2 is 4 to the AB. Multiply A and B. Number 3 is y to the 12a. See if you can do 4, 5, and 6. Use your calculator if you need to with the fractions, and then hit resume when you're done. Okay, number 4 should be x squared. Number 5 should be 10 to the 6th. And number 6 should be b to the 12th. Awesome. How about if I raise a product to a power this time? I have two things in the parentheses that I raise to a power. I'm simply going to distribute the power to every item inside the parentheses. So x will get an a, y will get an a. So let's write it out. For the first one, it's going to be x to the 4th, y to the 4th. The second one, distribute the power in. So 3 squared, a squared. Now that 3 squared can become a 9. So this is 9a squared. Number 3 is negative 2 to the 4th, b to the 5th to the 4th. So these are a little funny because they're not just one item. So you may want to put these in parentheses, especially the negative, because if you don't put the negative in parentheses, when you raise it to an even power, it won't give you that positive answer that you want. So take a minute, put this into the calculator if you need to. Pause the video if you have to. The answer should be 16b to the 20th. Okay, so I did this in the calculator, and I made this, and I multiplied them. Okay, number 4. We're going to take 4 and raise it to the 1/2, and then we're going to take x squared and raise it to the 1/2. So in your calculator, you can put in 4 to the 1/2. Pause the video until you've done so. So it should be 2x, because 2 times a half is 1, so 2x. See if you can try 5 and 6 on your own. Hit pause until you've done so, and then hit resume. Alright, so number 5 should be a to the 9th to the 2/3, b to the 27th to the 2/3. Then all you needed to do was multiply these two things together. So a to the 9th to the 2/3 is a to the 6th, b to the 18. And number 6, you should have done negative 3 squared, a to the 7th squared, and b squared. Now negative 3 squared is 9. 7 times 2 is 14, so a to the 14 and b squared. Alright, how about now if I'm raising a fraction to the power? Same concept as before, except you're going to distribute the power to both the numerator and the denominator. So x goes to the a power, and then so does y. Okay, so number 1 is 3 to the a over 5 to the a. Nice and simple. Number 2 is a squared over y squared. Again, nice and simple. Now, 3, 4, 5, and 6 are a little bit harder, because you could technically do number 3 in two different ways. You could simplify within the parentheses first using your exponent rules, and then distribute the 2, or distribute the 2 in to top and bottom, and then simplify it. So I'm going to simplify within first, just because I can. So I'm going to make this 2 over 17, a to the 8th, b to the 7th, and then I'm going to square that. Now where did I get these a to the 8th and b to the 7th from? Well, I took a to the 9th, divided it by a, subtracted the exponents, and got a to the 8th. Then I did b to the 8th divided by b has a power of 1, and I subtracted the exponents and got b to the 7th. So now I'm going to raise everything to this second power. So 2 squared is 4. Now we're going to do a to the 8th squared, multiply the exponents, a to the 16th, and then we're going to do b to the 7th squared, 7 times 2 is 14. And then on the bottom, we're going to do 17 squared. Now this is probably a number that you can get, but it's a rather large number, so let's just leave it as 17 squared for now. Okay, why don't you see if you can do 4, 5, and 6. These are a little bit on the trickier side, and remind me that we did those, and we'll go over those in class tomorrow, but I'm going to check to see that those are at least attempted. Alright, let's move on to the next page. Okay, now we have something called negative exponents and zero exponents. Zero exponents are fun because anything raised to the zero power is equal to 1. Whether it's inside the parentheses, like this whole thing being raised to the zero power is 1, or if it's just one little person. So n to the 0, definitely 1. 2 to the 0, definitely 1. This whole thing, 9n to the 0 power, 1. Now this one, negative 5n to the 0. I'm not raising the whole thing to the 0 power like number 3. All I'm doing is raising n to the 0 power. The 5 has its own power. It has a power of 1. So this is really saying negative 5 times n to the 0. N to the 0 is 1, and 1 times negative 5 is negative 5. Alright, same thing with number 5. I have n to the 0, which is 1, and I want to add it to negative n to the 0. Or in other words, negative 1. So negative 1 plus 1 gives me 0. Number 6, n to the 0 is 1, minus 2n, this whole thing to the 0 power. That's 1 as well, so the answer is 0. Now number 7 is fun because we're taking 5 to the 0 power. This is really saying negative 1 times 5 to the 0, which is 5 to the 0 is 1 times negative 1, which is negative 1. Same concept as 8, it's negative 1 times x to the 0, and x to the 0 is 1. So negative 1 times 1 is 1. Final answer. Alright, last but not least, let's move on to negative exponents. So if the exponent is negative, you can bring it to the denominator of a fraction and it becomes positive. If it's negative on the bottom, you can bring it to the top and it becomes positive. So this is like over 1 and over 1. So if it's in a fraction and on top it's negative, you bring it down, it becomes positive. If it's on the bottom and it's negative, you bring it up and it becomes positive. So let's look at this guy. C to the negative 4. All I need to do is say, okay, this thing's negative. Got to bring it downstairs and it becomes positive. But you can't just bring it down and not put a 1 on top. There has to be something there, otherwise it won't be accurate. So number 2, we're going to bring this guy upstairs to make it positive, and the placeholder would be a 1. So bring it positive, 4a to the 9 over 1, or just 4a to the 9th. Now some of you may be asking, well, why aren't I switching this 4? Well, what's the power of the 4? The power is 1. We only move negative exponents. That positive exponent of a 1's got to stay. Okay? Now number 3, it may be easier for you to distribute this negative 1 in first and then see what can be moved. So let's do that. We've got x to the negative 1, y to the 2 times negative 1 is negative 2. They are both negative exponents, so they both go downstairs to be positive. So x to the first, y to the second in the denominator, where the fraction on top is 1. Same thing with number 4. Let's distribute this power first. So 5 over a to the negative 6, b to the negative 3. Now, both of these powers are negative, so these have to go upstairs. 5 has a power of 1. That's positive. That goes nowhere. So 5 stays on top, and it's being joined with a to the 6th, b to the 3rd. You could write over 1 if you want to, but that's unnecessary. Alright, let's see if we can do number 5. So first things first, let's handle the parentheses. Let's distribute this in. So 6x to the negative 2, y to the negative 2, over x to the 5th, y. Okay, you could tackle this problem that you see here in one of two ways. You could divide by subtracting the exponents, or you can move the negative exponents to make them positive and then multiply. The choice is yours. I prefer to move the negative exponents and make them positive. So, the 6 has a power of 1, the y has a power of 1. So right now I have a positive 1, positive 1, positive 5. Those exponents and their bases get to stay. These two have negative exponents, so they have to come downstairs. So the 6 is on top, the x to the 5th and the y are already on the bottom, and it's going to be joined now with x squared, y squared. They're now positive. So your final answer is going to be, now I can multiply 5x to the 5th and x squared. That gives me x to the 7th. And now I can multiply y and y squared. That gives me y to the 3rd with a 6 on top. That's your final answer. Okay, see if you can do 6, 7, and 8. I'm going to check to see that those are at least attempted, and we will go over these in class. We are going to spend a tremendous amount of time on all of these exponent rules, varying levels of difficulty, of course, so please do not stress if this is difficult at this time. Okay, I'll see you tomorrow.